Okay, this is 2011, number 6. Again, it's a Taylor series one. Let's get some notation down. This is the graph of this. This is saying this is the fifth derivative, f to the fifth. Instead of saying f prime or f double prime, f to the fifth. This is the fifth derivative of our function. Okay, and then define our function to be sine x squared plus cosine x. And again, it says the graph of the fifth derivative is shown above. Okay, we're not going to use this graph until part D. We're going to use this to find capital M, where capital M is the maximum of some derivative, okay? So forget about this graph for a little bit and just focus on the fact that f is sine x squared plus cosine x, okay? Part A and B, pretty solid, okay? I'm going to move this up, so feel free to pause right now if you need to and kind of write this down. Okay, part A and B, pretty easy, and it gets you 6 of the 9 points. That's fine, you know? 6 of 9 points would be fine on this question to get a 4 or even a 5. Okay, so part A says, write the first 4 non-zero terms of the Taylor series for sine x, and write the first 4 non-zero terms of the Taylor series for sine x squared. Again, it's kind of the same, do you know what sine x is, and then can you make a substitution? So it doesn't even want the general term, it just wants the first 4 non-zero terms for sine x. So sine x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. You get a point for doing that. And then at 1-2 it says, write the first 4 non-zero terms for the series sine x squared. I don't really know why they kind of walked you through this. I would assume they just asked you this and you knew that then this is plugging in, but they wanted all of the work here. So you're just taking x squared and plugging in. So you get x squared minus x to the 6th plus x to the 10th minus x to the 14th. Right, you're just putting in an x squared into all of these things, and you know that I assume they want you to simplify. The rubric has it simplified, so I would. Okay, part B. Write the first 4 non-zero terms for cosine x, and then use this series and the series for this guy to actually write the series for f. Okay, so once you write this out, it's just making you show your work. Cosine x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And as a reminder, f, they define this for you, is sine x squared plus cosine x. Okay, so the last part of part B, it says, write the first 4 non-zero terms of the Taylor series for f. So we need to write f. Well, we know that f is just this plus this. This is just adding polynomials, guys. Nothing more. It's just here's a polynomial, here's a polynomial. F is this plus this. So add them together. So when you add these together, nothing would combine with the 1. So you get 1. And this is 1x squared plus a negative half x squared, which is going to give you a half x squared. Okay. This is, see how there's no x to the 4th? So there's nothing working with that. So that's just going to chill out. That's all by itself. Okay. And then this is, this is minus 1/6 x to the 6th minus 6 factorial. What is that, 1 over 720? X to the 6th, so you got to work with this. This is just adding a fraction. So this is, we need negative 1/6 minus 1 over 720. And that is going to end up being, what is this? This is negative 120 over 720 minus 1 over 720 is equal to negative 121 over 720. So that's what this silly thing is, minus 121 over 720 x to the 6th. All right, that is the first 4 terms. Again, all you're doing is taking this polynomial and adding this polynomial, and you want to get the first, I messed that up, and you want to get the first 4. So nothing goes with 1, neither of them have x's. These two combine to give the x squared term. This one doesn't have x to the 4th, so that one just gets copied down. Neither have x to the 5th. This x to the 6th is 1 over 3 factorial, which is negative 1/6. This one's negative 1 over 720. These fractions add, old school, like 8th grade, maybe lower, gives you this. So that's that number. Okay, so that is plus, of course, dot, dot, dot. That is f of x. Okay, part C says, this is just notation, f of 6 of 0. Now, what does that even mean? That's what is the sixth derivative of your function? Remember, your sixth derivative is this. Bingo, it's right here. Remember, what is 720? Now remember, 720 is really 6 factorial. So then your derivative is just staring at you right in the face. Negative 121. Like, what's the second derivative? Well, it's right there, 1. We know these things. What's the fourth derivative? Positive 1. What's the first derivative? It's 0, because there's no extra term. Remember, we know that when we write polynomials, we can just read off the derivative by looking at that coefficient. Right? Whatever that coefficient is, not if you combine them, then you're going to have to separate them. But again, this negative 121, that 720 is really 6 factorial. Remember, that's what 6 factorial was 720. It's the negative 121. Think about it. If you took 6 derivatives of that guy, you'd get 6, 5, 4, 3, 2, 1. All of those would cancel the 720 and you'd be left with that negative 121. Don't overcomplicate that. It's just looking off and reading something like that. Part D, I really don't like this part. This is my least favorite question out of everything we do here. It says, let P be the fourth degree Taylor polynomial for f about x equals 0. Using information from the graph of the fifth derivative shown above, show that the error, that's what that says, right? That's the fourth degree polynomial versus the actual function at a fourth, is less than 1 over 3,000. Okay? And what we have to do is, you have to use the fifth derivative. Again, look back at this stupid graph. This is by far my least favorite question. So we need to look at capital M. Okay? Use information. The fifth derivative, and again, we're looking from 0 to 1/4. So we're looking around there. And they make it just 40. Again, I hate this question. They say, I don't know what it is, but let's just make it 40. Again, you're looking for an upper bound estimate. So this information is telling you that capital M is 40. Stupid question. Okay, so then down here, we're showing them that the error between our polynomial and the actual function at 1/4 is less than or equal to capital M times x to the fifth over 5 factorial. And so when you slap all those numbers in and evaluate what this error is, that's 40 times 1/4 to the fifth over 5 factorial, and you get that to be 1 over 3,072. And remember, what do we want to show? We want to show that the error is less than 1 over 3,000. I just showed you that the upper bound for error is 1 over 3,072. So clearly the error has to be less than this, which is smaller than this. This is my least favorite question. Possibly, you know what? It might be my least favorite question out of all the AP questions. But I don't really dislike error, but I really don't like the capital M ones, and I certainly don't like this particular one graph of exactly why in the world they even used, 40 for that. I mean, it doesn't even get all the way to 40, but that's what they wanted to use, so that's what they did. Okay? If you have questions, you can see me, but again, you're using the graph of the fifth derivative to find capital M. Capital M is defined as the maximum of the next term's derivative. So we get 40, and then we just do 40 times x to the fifth over 5 factorial. We plug in 1/4 for x because that's what they tell us we want the error to be. And we evaluate that silly big number to be this, and it's less than that. Okay, so that's 2011 Taylor series. I really like part A. I like part B. I like combining these two things and getting some function and having to combine like terms. I like asking questions about the sixth derivative and you knowing that it's just that coefficient. But the error one, not a huge fan.